So this problem reads, how many of these molecules are polar? And the molecules that we have are SO3, OF2, BeCl2, CCl4, and O3. We're going to solve this problem by drawing the Lewis structures, then identifying the bond dipoles, then last identify the net molecular dipoles based on the molecular geometry. So we're first going to draw the Lewis structure to SO3. S is our central atom and the oxygen's bonded to S. We first are going to draw single bonds between S and oxygen, then place electrons on the outside of all the O's to make octets for all the oxygens. We know that SO3 has has 24 valence electrons. If we count what we have already put in, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, we have no more valence electrons to put for S. Because we are unable to make an octet for S, we can put double bonds between O and S to give S an octet. So our Lewis structure for SO3 would look like this because we have 3 good resonant structures. So all the oxygen and sulfur bonds will have 1 and 1/3 bond in between them. Now that we have our Lewis structure, we can now figure out the bond dipoles between S and O. We know that O is more electronegative, so all the O's will have a partial negative charge. And sulfur will have a partial positive charge. Now we can draw our bond dipoles going from positive to negative. Now we can draw our molecular geometry, which is trigonal planar, and we can put the dipoles going from S to O. We know that all the domains are equal in this geometry, and we know that the dipoles will cancel because the domains are equal, so therefore this molecule is nonpolar. For our next molecule, OF2, F has a partial negative charge because F is more electronegative than O, and O will have a partial positive charge, so we would draw our dipoles going from O to F. Because OF2 has 2 non-bonding pairs of electrons, the molecular geometry will be bent. Because it's bent, that means the domains are not equal and the dipoles do not cancel out, so the net dipole will be pointing down. Because there's a net dipole and the dipoles do not cancel, this molecule is polar. The next molecule we have, BeCl2. Cl is more electronegative, so it has a partial negative charge, while Be has a partial positive charge. So we would draw our dipoles from the partial positive charge to the partial negative charge. Since our molecular geometry is linear and all of our domains are equal, the dipoles will cancel, there's no net dipole, and that means this molecule is nonpolar. The next molecule, CCl4, Cl is more electronegative, so it has a partial negative charge, while C will have the partial positive charge. So we can draw our dipoles going from C to Cl for each bond. Our molecular geometry is tetrahedral because we have 4 domains, and because all the domains are equal and the dipoles cancel and there's no net dipole, this molecule is nonpolar. In our last molecule, O3, we can draw 2 good resonance structures, making this Lewis structure here. Our molecular geometry will be bent due to this non-bonding pair. Because of this non-bonding pair, the domains are not equal, which makes this polar. So out of these 5 molecules, only OF2 and O3 are polar. Some common mistakes would be not calculating the number of valence electrons correctly, forgetting the octet rule, drawing the dipoles the wrong way, and confusing domain geometry with molecular geometry.